Hi, we're going to look at implicit differentiation. If you'd like to, I'd recommend to turn to page 254, where you'll see this example, and that's what I'm going to work through today. So what we've been doing previously is when we've got a function y equals in terms of x, then we can just directly differentiate dy by dx and differentiate along all my terms. Or if we can rearrange something where we've got y is equal to x or x is equal to some function in y, then equally we can differentiate and work out dy by dx. When it's not easy to rearrange into a format where you've got x equals or y equals, and you can use implicit differentiation. And what we're going to do is we're going to work our way along term by term and differentiate with respect to x, bearing in mind that this function here, this is y, is a function in terms of x. So first of all, we can differentiate x cubed, 3x squared, and then plus x, the coefficient here is 1, so it's going to be plus 1. When I come to differentiating this, I'm going to have to use the chain rule. So what I'm going to do is I'm going to differentiate with respect to y first. So I've got plus 3y squared. But I'm working out dy by dx, so what I'm like differentiating outside my brackets, and then I need to multiply by the derivative of the thing inside my brackets, my function here. So we're going to multiply by dy by dx. I'm going to write this as y dash. When I write y dash, I mean dy by dx. If you look at the example in the book, they do dy by dx all the way through. I'm just saving time. Plus, and then 3 multiplied by the derivative of this. This is 3y dash is equal to, and then if I differentiate 6 with respect to x, I just have 0. I want to get dy by dx is equal to, so what I need to do now is get all my terms that don't have this y dash thing in them, and put them onto the other side of my equation, and then factorise out my y dash so I can get y dash is equal to something. 3y squared y dash plus 3y dash, that's these two terms, is equal to minus 3x squared minus 1. Now I can factorise out y dash here, y dash, 3y squared plus 3 is equal to minus 3x squared minus 1. And now I can divide through by this thing here, so I've got dy by dx is equal to something. Y dash is equal to minus 3x squared minus 1, all divided by 3y squared plus 3. And this is my derivative. Example 24. So example 24 is this function here. We're not just trying to find the derivative this time, we're trying to find the derivative at the point 1, 1. I'm going to start off by differentiating everything and differentiating with respect to x. Here I can see I'm going to have to use the product rule because this is a function of x and this is a function of x. I'm multiplying these two things together. So I'm going to start off by leaving this as it is. For x, that's my u. And then I'm going to differentiate my v, which is y squared. And so to differentiate my v, I'm going to have to multiply by 2y, and then drop the power by 1, so this is 2y, 1. And then I have to multiply by the derivative of y, so times y dash. So this is starting off my product rule. So I'm using my product rule, and then I'm using my chain rule. Now I'm going to finish off my product rule, plus, and then this time I'm going to leave this as it is and differentiate this part. So the derivative of 4x is just 4, and then y squared can just stay. Now I'm going to go on to differentiating this thing here. You could use the quotient rule here because you've got u over v. However, what they do in the book to make it a little bit easier is change this to 6x squared y to the negative 1. Because now here you can see I use the product rule because I've got u times v, and the product rule is slightly easier for us to use. So we'll go ahead and do that. Plus, then let's leave this thing as it is, 6x squared. Now I'm going to multiply by the derivative of this thing. The derivative of this thing, we need to bring down the minus 1. So this is going to become minus y to the minus 2. And then I'm going to multiply by the derivative of y, which I'm doing as y dash. And then lastly, plus differentiate this thing here, which is going to be 12x, and then leave this thing as it is. So y to the minus 1 is equal, and then the derivative of 10 is 0. Now I could try and rearrange this so I've got y dash is equal to, if I wanted to find the derivative. However, I just want the derivative at the point 1, 1, so it might be easiest to just come along and start off my substitution. X equals 1, y is equal to 1. And then now you're just going to plug in 1 everywhere in here. So 4 times 1 times 2 times 1 is 8. Y dash, 4 times 1 squared plus 4 minus 6 times 1 times 1, 6 y dash, and then I've got 12 times 1 plus 12 is equal to 0. And then if you rearrange this slightly, you've got 8 minus 6 is 2, 2 y dash is equal to minus 16, y dash is equal to minus 8. And there's your second example. Example 25. Again, I'm going to use my implicit differentiation, so I'm going to work my way left to right and just differentiate everything with respect to x. Here again, I've got this times this, I'm going to use the product rule. So I'm going to start off by leaving my e to the 2x as it is, e to the 2x. Then I'm going to differentiate ln of y. So the derivative of my ln function is 1 over this thing. So this is 1 over y. But I'm going to have to multiply by this, because y is a function of x, times y dash. And then moving on, plus, so I'm finishing off my product rule now. I need to differentiate this e to the 2x thing. So that's 2e to the 2x, and then I can leave my ln y as it is equal to, the derivative of x with respect to x is 1, the derivative of y with respect to x is dy by dx, and then my minus 2 will just disappear. And then again we're working out the derivative of x equals 1, y equals 1. So let's substitute those in a bit. So I've got e squared, 1 over 1 is just 1, this is y dash. And then I've got 2 e squared. And then here I'm doing ln of y, which is ln of 1. And if you think about what ln is of 1 is, this is e to the power of something is equal to 1. Well, what would I raise e to the power of to get 1? That's 0. This is multiplied by 0, so this whole term is just going to disappear. Is equal to 1 plus y dash. And so now I need to rearrange this thing slightly. I could go and evaluate and see what e squared is, but you're going to get some horrible decimal. It's nicer to leave it as it is. So let's get my e squared y dash. I'm just going to bring this y dashed over, minus y dashed, to get all my derivative terms into one side, is equal to 1. Now I can factorise out y dashed. Y dashed is e squared minus 1 is equal to 1. And then now I just divide through. Y dashed is 1 over e squared minus 1. And as I said, this is a number that you could put into your calculator and work out, but it looks nicer left like this. You'd usually leave it in exact form unless asked otherwise. I hope you understood all that. If I went a bit too quickly or you want me to go in more detail, let me know in the forum, and I can put up something that goes a little bit slower or talk you through it again in some way. Alright, have a nice day.